We kind of bumble along. We make people feel better about themselves.
They're like, if these two fucking idiots can do it,
Yeah,
then anybody
exactly.
can. Yeah, that's how
Exactly.
I
Right. And
feel.
that's kind of true. That's kind of true.
Yeah, that's how I feel, man. Anytime someone says, "Oh, I can't do it," to me, I just hear, "I gave up." It's just a matter of like brute force effort. Like nobody, it's not easy for anybody. It's just some of us are used to the pain and suffering more than others.
Yeah. It's not the whatever, the dog and the fight and the dog. And why are we talking about dog fighting? Hello, world. We are back. This is Sean and Joe. You got something to say to the world, Joe?
Hey, Sean. Hey, world.
So it's been, I don't know, what, a week and a half since we talked last? What have you been up to lately?
It feels like it's been months. I did orientation in Meta. I'm living in a small apartment with my cat in New York now.
Oh, nice.
And I've been reading the operating systems book I told you about. Yeah. My new
Very
team
cool.
is so cool. Everyone's super smart, really friendly and helpful.
Nice. What's the Meta office like that you've been going to?
It's the old Farley building above Moynihan Hall, and it's these giant rooms, like 50 feet tall. It's really wild.
Very cool.
There's like,
You're still getting settled then?
yeah, I'm in between places. So I'm in temporary housing and I got to find a place. My wife and daughter came up for a little bit. They're back in Virginia, but they're going to come back soon.
Sweet. That's awesome. I'm glad to hear the orientation's going well and hope the real estate market cooperates with you.
Yeah, I think we're renting, man. It's just pretty brutal.
Yeah, that's probably a smart idea. All right. I would like to share my screen. Okay, cool. I've gone ahead and copied over the C source code from Compiler Explorer, which we were using last time, and now we are in Replit. So we've got that quote unquote multiplayer thing going. And just in terms of what to cover, I was thinking we could talk about concepts, handle any questions if you want. We could change up the code example here as well. And then after that, maybe briefly hit on operators so we can form expressions. I think a lot of this is pretty standard across most different languages, but C has like some more low level stuff, which we might want to dial in a little bit more on. After that, we could talk about some of the code examples you've been seeing in the operating systems book.
Hell
How's that
yeah,
sound?
let's do it.
Nice. So last time we were talking a little bit about types in C, and we went over all the different scalars and went over some complex types. And then we went over, I think, some crazy declaration syntax. We talked about how, like in C, when you declare, you've got the base type, and then you've got this crazy declarator thing, which can lead to these absolutely complex looking types here. This still look pretty frightening to you?
It just looks like a wild syntax.
Yeah.
Yeah, it's too constant.
Yep. So this is
And
the
it's
constant.
maybe unused. Those concepts to me do not work together.
Yeah, it's a utterly useless line of code. Why in the world would someone ever do this?
Of
I'm
course.
just trying to make it look intimidating. So we went through the different scalars and we talked about how these are different widths. And if you look over here, like we can see these different widths. So the way we were
Oh,
looking at this before was we were actually looking at the assembly output by Compiler Explorer. We can't really see that here in Replit, but now we're using like the main function here to go ahead and print things out. So we're using printf, and we've got these special format strings And so this LU is basically a unsigned long,
Okay.
right? And then we are combining that with the size of operator to get the size of these different objects. We've got A, B, C, D, E, F, G, H, A, B, C, D, E, F, G, H. One thing that might be interesting here is, so short, like we talked about short and long. So if you want, you can actually make this type more verbose. So you can have short int,
Unbelievable.
you can have regular int, you can have long int, you can have long int. And then you could make all these unsigned, right? We could have unsigned short int, unsigned regular int, unsigned long int,
And
unsigned
just to
long
ask
int.
a dumb question,
Yeah,
unsigned means that it's not negative, right?
yeah. So unsigned means it's not able to store a negative number. So that for an unsigned number, the smallest is 0.
What about a long
And
float? Isn't that just a double?
a long
Or du-
float.
No,
Okay, yeah. So we don't have these here. So let's do float
that was probably wrong.
I and then double J. And then, oh, come on. And then there's a long, yeah, long double K. So those are your 3 floating point types, but they don't have signed or unsigned. They're just a little bit different.
Wow.
These things can get like crazy verbose. Believe it or not, we have actually an unsigned char. We have a signed char.
That doesn't make any sense. Is it because it's just integer under the hood?
So previously we talked about how on different platforms, like the sizes of these different types can vary. And we looked at like how on Intel versus PowerPC, like the size of the long int was different. One of them was, I
Mhm.
think, 64 bits wide. One of them was 32 bits wide. Similar to that, the signed or unsigned thing for char is unspecified. So on certain platforms, char defaults to unsigned, on others it defaults to signed. And because there are like 2 different versions, you have to be kind of more pedantic sometimes. Just a little bit of esoterica, but I wanted to expand out some of the crazier types here since you're having fun with the more complex types down here as well. We
Yeah,
could combine this with pointers, we can combine this with functions, we can make some truly crazy looking types.
it's scary. Shaking in my boots.
There you go. And
Dare I say trembling?
trembling. So I think that's caps off the types here. Let's talk a little bit about operators. In general, like all of the kind of C family of languages have similar sorts of operators. So like in JavaScript, pretty much all these are the same. Um, even weird stuff from C, like the ternary operator, is in JavaScript. So conditional, that kind of thing.
I was wondering if that was going to be in C or not because they took it out of Go.
You took it. Okay.
You can't do that in Go.
Yep.
And so when I saw it in C, I was like, whoa. Threw me off because I thought C was this like ultra simple language.
Yeah. So I think kind of the backstory for that is that basically Ken Thompson kind of like the syntax of how this stuff looks, I believe. And then that's kind of how we got these unusual looking operators. I think he said it was more expressive. So I don't know exactly what that means, but that's just, I think that was the word. And then C got super popular. And so then when C++ got developed, they basically extended C, right? So C++ picked up all that stuff. And then when Java came out later, Java basically wanted to make the language super approachable for people coming from C or C++. So they took all the same operators, basically. I think probably I forget if they have bitwise. I think they do, but I'm not sure. And then JavaScript, what Brendan Eich did his like 1 week thing, and he's like, I want scheme in the browser. And then Sun is like, you got to make it just Java because you're JavaScript now. We made a deal. And so then like JavaScript got this too. So it's been kind of like viral, I guess.
I dig.
You
Man, I'm
dig.
so glad I don't have to do practice bitwise operations in Leak code anymore.
Ah, yeah.
But hey, who knows? Maybe I'll use them for real.
Well,
That's
yeah,
another.
it's a fun optimization for all sorts of stuff. And definitely in C and C++, it gets used quite a bit. So let's go ahead and just like comment out these guys. And let's fiddle with some operators here. So if we do a printf, going to print out printf integers here. All right, so 42.
It's the
Run.
meaning of everything.
Meaning of everything. All right, so I believe you should have a cursor here.
You're a prophet, man.
Um,
You're sharing. You're sharing it. The meaning of
wait,
everything.
I'm sure. Oh, okay. Yeah, yeah, yeah. I'll change it.
You're a prophet.
There we go. So why don't you go ahead and hit control and then put your cursor right on that 31, and then just go ahead and try to put in some expressions using the
Sorry about
operators you're
that.
familiar with.
That I'm familiar with. I know how to do addition.
Yep.
I run it.
Yeah. Okay.
Boom.
Boom.
Subtraction.
Yep.
Boom.
Boom.
Mod. Boom.
This is
Uh,
fascinating. The
yeah.
viewers are really gonna love this.
Yeah. Okay. I dude, can we talk about something interesting?
Yeah, yeah.
Let's let's talk about how you would do object-oriented style programming in C without C++.
Okay. Yeah, yeah, yeah. I'm happy to do that.
So I kind of learned a lot on my own since we last talked, and one of the things I was curious about was like if it was possible. And then once I found out that it was possible, I wondered why do we have C++? Because like the whole point of it was to do that, but it's already doable in just regular C.
Yeah, yeah, yeah. Yeah, that's a good observation. I mean, generally C++ turns into assembly code, and so does C, right? And C happens to be a lot closer to assembly. So it's kind of like anything you do in a higher level language can be somehow expressed in C, um, maybe with a lot more code. But yeah.
Because like, can't you do like a type def struct, and then instead of that you have like a pointer, I think you do like void like that,
Yeah.
or
Yeah, so type def is one word.
type def is one word.
Hmm. And then you put your alias at the end of the curly block,
And it would be like
a widget or whatever.
yeah, widget T.
Sure. Yep.
And then you can define like you can define do you know how to do this?
Yeah, yeah, yeah. Do you want me to walk through some examples?
You tell me what to do.
Okay, cool.
Explain it to see.
So,
Let's see if you can explain it well enough for me to program it on the
all
fly.
right, yeah, happy to. All right. So first off, that widget underscore T thing, um, that underscore T is kind of the traditional POSIX, Unix, C way of defining a type, but a lot of different code bases.
Oh, cool. I was wondering why that I saw that everywhere.
Yeah, right. So it's it's more common in C, you'll see it, but a lot of code bases will do more like the C++ style, which would be like get rid of that underscore T and just make it a capital W widget. So either way is fine. Okay, cool. So you want to actually you want to define one of these widgets?
Yeah, I think you have to do this. I think you have to do like struct uh like widget T pointer self. I think
Sure.
it's like
Yep.
it's like kind of like classes in Python.
Hmm.
I think that's how what you're supposed to do.
Yeah. So basically you've got like a context object there and it's got like an A and a B and you want to add. Okay. Okay, there we go. More stateless.
And then instead of doing this, we call it this like int, right? And then instead of having it, we have like a dumb math helper.
Yep. Okay.
Okay, and then I think what I need to do is create a constructor, right? So I have my like class definition. This is like the implementation,
Hmm.
and then the constructor would be like dumb math new. Is it just telling me what to do? Is this correct?
Oh yeah, we got all these AI features. This is cheating. We're vibe coding.
I did. I did it.
All right, hang on. Now let's look. All right, we got our replit agent thing. All right, dumb math new. We're returning a pointer to dumb math. All right, we got a pointer named self. Okay, we malloc
Why
a.
don't we just do Malik's? Why does this have the why is it casting it? Why is it not just Malicing it?
So this is basically something that it kind of depends on how your compiler is set. So in C, you are allowed to cast from a void pointer, which is what malloc returns, to any pointer. But in C++, that's illegal. And you can also tighten down your C compiler to make it illegal. Basically, the thought is that it's a dangerous cast to implicitly
Anytime you
cast.
malloc of size of the struct or a type definition.
Yeah, so this would be valid in C and C++. So if you get rid of this, this should still compile in C. But we got a bunch of other errors here. Okay. Fix that up, comment that out. Okay. Struct dumb math declared inside parameter list will not blah, 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 blah. Okay. Hang on here. Let's work through some of these. All right. So struct dumb math declared inside parameter list will not be visible outside of this definition or declaration.
Oh, is my pointer in the wrong place? No, my pointer's in the right place.
So basically the issue is that there's two types of names. This is kind of the shorthand name. And the shorthand name, you can do something like that. The long form name requires the struct keyword in C. Yeah, and so within here, we need that defined. Okay, now conflicting types, right? We already had a D. Get rid of those. Run again. All right, error unused parameter self. Do that to silence it. Implicit declaration of function malloc. Okay, we got to import the header. All right, there we go. So now we're compiling, and I totally lost my train of thought. All right, so I think you were asking about the cast here, and when it has to be explicit when you get a malloc.
Yeah. So is it so it compiled now? Why do you have to say maybe unused?
So maybe unused is required here because we have our compiler setting to treat warnings as errors, and we're not assigning it
Okay.
to self here.
Oh, okay. So we're being a little bit annoying with
Oh
our
yeah.
error handling.
Yeah, we have it turned up. We're being pedantic even.
Yeah, it's because so we didn't. Okay. I would rather just turn that off. Can we just turn it off? Because maybe unused looks so bad.
Sure. Yeah. All right. So if we go to our make file, we can.
I'm not scared of no C. Come at me.
All right.
Try,
Let's
try
do.
to
Yeah.
try to leak my memory. I'll
Let's do
fight you.
this. So now you'll get the warnings, but not. It shouldn't break.
Oh, should we so whatever we make with it. Okay, so pedantic is what's warning us. Or is it W extra?
I can't remember.
Okay.
Yeah, I can't. I'm not sure which one.
That's cool, man. Okay.
But yeah, now we get the fuchsia warning here, but we're still building.
It's a beautiful color.
Yeah. All right, cool. So we have our vibe coded new function here.
Well, that's the only
And
way I do it.
and that looks vaguely functional. Um, sure. So how would you go ahead and call add?
Oh, do we need to put this above the main function to run it in the main function?
Yes, you do.
Okay, I'll
Yeah.
do that. I'll move this.
Yep.
I'm gonna just delete stuff because like we don't need to keep old stuff, right? That's
Up
what
to you.
memory,
Yeah,
that's
up
what
to you.
memories are for. It'll just like keep it, oh, whoops, what did I do? Let's just keep it concise for the episode.
Okay.
Boom. So what we can do is we can go DOM math,
Hmm.
and then we do like, oh, dude, look at that. Why is it adding it like this? Shouldn't it just be like this?
No, because you've got a self parameter there. You can get rid of that self parameter the way you have it now, though.
But don't we want the self parameter so we can do the reference here? Oh no, self is only, we only need the self parameter if there's actually things in it that we want to be able to
Yeah,
access.
there's no state in there right now, so you can get rid of it for now.
Okay.
Okay.
Boom.
Nice. All right. I feel like the agent is doing a bunch of the work here, but we're good. We're moving along. The all right. So you have a function pointer here, and it's kind of like wrapped in this like dumb math thing. The struct is really doing nothing here. We got our extra struct here, and then we are for some
Well, no,
reason
no, it's not doing nothing.
okay.
If we want to write a unit test library, for example,
Yep.
we can write a unit test library for the type definition. And then if we ever want to implement a new version, we can do that in a completely separate space, isolated from the original code. And if we can verify if the unit tests pass, then we're good.
Okay. Cool. Yeah. All right. So you mind if I drive a little bit here?
Hell yeah.
All right. So one thing here is we are allocating our struct on the heap, and there isn't necessarily a reason to do that here currently. So if we want, we can also do that on the stack. And there we go. What am I doing wrong here? All right. Initialization of dumb math pointer from incompatible pointer type. Dumb math. All right. I got to do this. Okay, cool. Yeah, so now we have an equivalent struct on the stack. And since it's on the stack, we don't use the arrow operator. We use the dot operator to call. And all right, so now we're calling off the object on the stack.
But isn't this bad? Because the reason why we want to use malloc is that it gives us back a pointer, and then that way we don't have to create more than one copy of dumb math.
I mean, it depends. It depends how this is used. I would say for these sorts of interface objects in C, it's not uncommon to see them as like a global is one. And then when you pass them in, you might actually pass it in as a literal. So we could also do kind of a crazier thing here. Yeah, there we go.
Bro, what? That should be illegal.
All right.
There's no fucking way that works.
Yeah,
Yeah.
that works.
What am I
Yeah.
looking at?
Yeah, so this is constructing
What?
a temporary dumb math.
Oh my God.
And so like if you're testing functions that take a dumb math object, like this would be you'll see more of this. Sometimes people will in C use like macros to clean up the syntax there a little bit. But yeah. Yeah, I would say as much as possible try to avoid the malloc. But
John, I hate your advice. I'm not learning C. If for anything else, can I tell you what I did last night?
yeah, tell me.
Can I share my screen? I can show you.
Go for it.
Let me open up. Okay. So one thing I've been slowly trying to configure NeoVim.
Mm-hmm.
So that's like one thing you'll see here. I'm working on, this is my memory module. So I wrote this program,
Mm-hmm.
and basically it allocates a set of memory,
Mm-hmm.
and then it just displays how much memory of that, like the memory allocation. And you can just like arbitrarily put an amount in there. And yeah. And this is the magic here, down here on line 78. This like this wild beast of a thing. And it's just
Okay.
basically trying to just insert data into an array, and
Mm-hmm.
it just keeps going. It just goes
Well,
burr.
you were mentioning that when you run this, your fan spins up like crazy, right?
Yeah. It's wild. It's like 100% CPU usage.
Yeah.
Yeah. This is what happens when
I don't. Maybe you shouldn't run it. Maybe you'll crash out of the stream. I don't know.
no. Let's see how much memory I'm using right now. Free.
Okay.
Okay, I got plenty.
Uh-huh.
Let's do 30. All right, 20. Yeah, 30. Fuck it. Is that too many zeros? I don't know. What's gonna happen? Oh, it's too many zeros. Is
All right.
this
Let's see how
visible?
your
Can
stream
you
holds up.
can you hear that?
Yeah. Wait. No, I think our editing software is cleaning it up too much. I can't really hear it.
But it's going burr.
Yeah.
We can do free. Well, yeah, that's it. That's what I did last night. So
Okay.
now I feel like I have all the power.
So can you explain to me why your processor runs up so hot?
Because what do you mean? Oh, because it's streaming it as fast as it can.
Yeah, your while loop basically just goes over and over and over as fast as possible.
Yeah, and then you say it, and I have nothing else running except
Yeah.
for the browser.
All right. Well, hopefully your system calms down.
It did,
Um,
it did.
okay, but I guess your point is like, hey, look at this very advanced looking POSIX Unix code. You're coming at me with this basic object oriented stuff. You want me to bring the heat. Is that what the takeaway is?
What? No, what I'm saying is it's just like the point of C is to be able to have control over your stack and your heap and your
Yes, that's true.
virtualization.
That's true. So that's why we have two alternatives here, for sure.
The third one though, man, go just get away, get that shit out of here.
I mean, sometimes you just want a temporary, right? You don't necessarily want a identifier attached. Um, but yeah. So let's mess with this some more. All right. So, all right, we've got add. Let's do a sub. Okay. Okay. Please yell at me if I do something wrong.
You don't deserve it, Sean.
That's very kind of you. X file busy. Just weird replit problems every now and then. Okay. All right. So now we've got an add and a subtract. I guess let's call that. All right. Nice. Look good so far?
Did you run it?
Yeah.
Hell yeah, -1.
-1. All right. So you're bringing up that actually the cool thing is you can basically have different backing functions that you register against the function pointer, which fulfill the common interface.
Yeah.
Yeah. Can you think of an example of another type of add that you might be interesting here?
You could add floats. Or I guess no, because here the definition is integers.
Yep.
So I think maybe for this example, this is like such a simple problem, it doesn't make sense.
I would like to suggest one alternate add, which I think might be kind of interesting here. All right. So first, let's call this safe add. And can you think of an example where
Unbelievable.
adding is unsafe? Up, up. Oh no, it's given some answers.
If x is greater than 0,
It's
what?
gone. I moved.
So
All right.
why would it be unsafe to add if they are less than 0?
It shouldn't be necessarily, but so we have something called int max, right? And our agent is auto completing with interesting stuff here. All right. So int max is the largest number that can fit in an int.
Okay.
And if you add 1 to int max, you overflow.
Okay.
And overflow of signed integers is undefined behavior. Undefined behavior basically says if you do this in a program, the compiler makes no guarantees of what's going to happen. The joke people say is a demon might fly out of your nose, a nasal demon. So, so if you write UB, you get nasal demons.
I don't want nasal demons.
Yeah.
Get that.
So
Get away
then
from me.
right. So then if you don't want to overflow, I mean you could assert something like that, right?
And then it would panic. It would just crash it if it's false.
Yeah, it would crash out the program.
Yeah.
You could, I mean, our signature here doesn't really give us a lot of options. Oftentimes, like the signature of these kind of safe ads will be like something like that. So you've got multiple values getting returned. And this is like the return is like a did succeed flag or something. So then I feel like this agentic vibe coding stuff is kind of taking the fun out of it a little bit here. But
Yeah, why don't we
um,
just disable the agent?
I have no idea how to do that. That'll be my homework for next time. But
Okay.
all right, so this is one type of overflow, right? So if these two add up and they go over int max, but you can actually do overflow on the negative side as well, right?
Oh
So
shit.
there's like an int, is it
I
min?
like this. I like the idea of having the pointer, you passing the pointer, because then that makes it so if you are only passing things as pointers when you want to free memory, you only you can like always free at the level that you declare the variable. So if instead of, does that make sense?
No. Yeah, go ahead. Take over.
Where is, sorry, it's taking me so long. We can edit that out, right?
We've got the power.
So basic, yeah. So basically, let's say we have a function and it's called, it returns a bool and we can call it, yeah. Uh, uh, yeah, we can call it make me sandwich.
Okay.
No, what are you doing? And then we can say like sandwich. Dude, I don't want to say ham and cheese. I just want to say like X. And then we can return true. Then we can say if how do I disable this fucking thing? Enable off. Oh my god. Dude,
Maybe it's this thing. I
that
don't
was
know.
killing me. Does not equal null.
I think I turned it off.
Return false. Okay. So let's get rid of this for a second. If that's okay. So basically, let's say we have a Sando goes null, right?
Okay.
In this case, do I need a malloc? Yeah, because I'm trying to demonstrate that. And this would be a pointer.
Okay.
And so then if we say like bool okay equals make me a sandwich, and then we pass it Sando, then we can like print Sando, and then we can free Sando at the end. I think it's print F, right?
Printf.
And we can do something like if not okay. How do I just like return one? Be like print F. The meat is cooked. Boom. Okay, I'm gonna do it.
Comment that out or something. What do you...
I'm trying.
Okay.
There we go.
All right. So you got some seg faults going on, I think.
Yeah. So it gave me the meat is cooked,
Yeah.
which means that sandwich is not null. So shouldn't this be
Yes, that's right.
null?
Yeah. Now you got
Now
your
that's
seg fault.
causing a seg fault.
Yep. What's happening on line 62 here?
I'm trying to free the memory. Well, that's why I used malloc, because I was trying to demonstrate something with free.
Trying to demonstrate something with free. Okay. What's happening right here on line 47
Uh-huh.
is you are declaring a character literal.
Uh-huh.
And that is going into a special part read-only section of your binary,
Okay.
and that resolves to the address pointing to that. And then so you're setting that to sandwich, and when you try to free an address in that read-only section, it goes segfault because
Okay, so
it's
do
in
I
the
do
wrong segment.
copy of X? Do I have to like pass copy of X or something? Because all I'm trying to do is I'm trying to just set this character to a value and then
Yeah,
free
yeah,
it.
yeah. So there are string.h utility functions you have to use for that basically.
Can you take over and fix this?
Yeah. So I guess before I go in here, like, what's the kind of overall goal you want to hit?
The goal is that like so if you pass a pointer to what you want to where you want to store a result,
Hmm.
then when you're trying to manage your memory, you can always assume that you should free whatever you allocate at the same organizational level as where you declared it. So Sando is declared in main, so
Yep.
then Sando can always be freed at the end of main or
Yep.
somewhere in main. If you're passing a value
Yep.
as the return type and you're creating something new, then tracking where you free it, where you have to free it, is going to be in a different place than where you declare it, which is going to that's going to be harder to manage. Like that'll make it harder to manage where you need to free things in your code base. Because if you can declare and if you can allocate memory and free memory in the same level of
Hmm.
code, then you can guarantee it's easier to guarantee like that the memory that it's available when it should be available.
All right. So I took out the utility function, but like here's kind of the core, I think the core piece you're talking about. So we're allocating an object on the heap here,
Yeah.
and buff size is a macro, one of those POSIXy, Unixy macros, which I think is like 4096 usually, something like that. So we end up having a buffer on the heap for some number of characters. We don't actually use it now, but then at the end we free it here. So like you want to set a value to the string.
Yeah.
Yeah.
Ah, that's what I was doing wrong.
So that I'm being a little pedantic here, but all right. So here is
Oh, that's cool, dude.
basically going character by character to assign, right? So this is kind of like the crudest way to do it. So when we get our pointer back, we can use the this operator, and it basically will convert into pointer math and generate an offset to the address that we're setting the character. And that's how we get high here. There are basically functions for this, like go over here. All right. All right. Where's my headers? How do I?
You gotta just scroll up.
Okay. Here we go. Strings library, null terminated byte strings. So we have a bunch of functions in here in string.h. So if we include string.h, we pull in the declarations for all these, and then we can use them. Stir copy is the unsafe. Stern copy is the safer. And so we can go ahead and use this. All right. So here's the parameters and the return value. All right, so we take the destination first, then the source, then the maximum number of characters to copy, and we have this even safer one that has the count, the size of the destination buffer. And we get a copy on success, or no, excuse me, a 0 on success, a non-zero on error. Okay. I feel like we need to do some special macro definitions to be able to have access to that. So let's skip that for now. All right, we are writing to Sando, and we are
Colonel
writing
Sando.
I, and we are writing 3. Okay. Returns a copy of destination. All right, so we don't have to really check anything there. There we go. All right, so now this is like equivalent to this basically.
With the malloc, or did you still need to do malloc?
The malloc is up here.
Oh, and now we can free because we created the copy.
Yeah.
But yeah, so basically like when we care about Sando, because we're passing the reference or the passing and we're using a, then we can free it at the same level.
Mhm.
Which is just it makes memory management seem easier instead of having to like worry about like values declared inside of string. Like if you allocate something inside of string copy, then and just then you have no idea where it needs to get because it could be used. It could you got to really follow the stack trace.
Yeah, that sounds good. So you're basically saying allocating the object here and freeing it in the same scope, in this case main, makes it easier to like visually inspect and validate that you're not leaking memory.
Exactly.
Okay. Yeah, cool. I feel like we took a little bit of an aside from the object-oriented piece. So,
I mean, I think we just kind of talked about like what's cool about C.
yeah,
Which
well,
is
there's a lot of cool stuff.
that you can kind of do anything. Like it's not gonna hold your hand.
Yeah. Well, I guess let's go ahead and let me rush through a little bit about what you were kind of asking earlier for object-oriented coding in C, because I think there's a point where you had like a self pointer and you were wondering why you had to pass in the address of the object. So let's just hit that really quick. All right. So we got a struct context, and it has um, an A register, and we have add, and it takes a value.
It could be
And
like
basically,
yeah, no, keep going. Sorry.
and so basically, if you pass in a value here, we want to add it to A, which is like an accumulator. Does that make sense?
Yeah. Okay.
All right. All right. So then
An accumulator is a type of iterator.
an accumulator is like it's like a variable, I guess. So if we do context init and we take a struct context, if we initialize this, let's just set A to 0. Okay.
Okay.
And then now let's do the add function. Oh, okay. And so now we have context, and we can do our assignment operator plus equals val. Okay. And so now if we construct this, all right. Okay, cool. So basically now here's an example of using our struct context and declaring an object of that type on the stack. Then we bind the function pointer to a concrete implementation, context add, and then we invoke our initialization function. When we do that, we have to pass the context object with the ampersand here to basically turn it into a pointer to the context. And then we can invoke the method here. But when we invoke the method, we have to basically handle the binding to the this or self every time, right? So we have to pass that ourselves here. And so initialize sets a to 0, then we add 5, and then we get 5 out at the end here. So the main thing you get from C++ is just a lot cleaner syntax.
Yeah.
So if this were C++, it would look something more like this. So like the main thing is the initialization function gets combined with the declaration here and gets invoked automatically. We don't have to pass the pointer for the this context. It's bound automatically. And that means that when we call the method, it's basically just behind the scenes and we don't have to worry about it. If we were to then also wrap this in a scope, at the very end here at the end of the block here, we would automatically run what's called the destructor, which could handle cleanup or freeing of pointers and stuff. So then like down here, we were talking about how it's cool that you can try to keep your allocations and your frees in one scope to be able to visually track them.
Yeah.
With C++, you don't even necessarily have to call free in some cases. It'll be automated for you, kind of
Or
similar
you'd
to
be calling it in the destructor.
Yeah, that you'd have that same kind of free logic inside your destructor, and it'd be invoked automatically, which will
Cool.
eliminate some of those memory leaks.
This pussycat one. Love. Say hi, people. Well, dude, we've been going at it for an hour.
Yeah, yeah. I know we went a little bit all over the place, but what are your takeaways from today?
It's just fun to learn. And as
Yep.
long as you approach things with childlike sense of curiosity, you can be old like me and learn lots of new things and get paid good money for it.
Nice. Yeah. It's a good life philosophy, I think.
Yeah, never be done learning, man. It's not worth it.
Yeah. So speaking of learning, what are you going to be pushing forward on?
I'm going to keep doing the operating system stuff. I learned about processes, threads, CPU virtualization, and I'm learning memory virtualization right now. I learned about the heap, the stack, and now I'm going to learn about hot swapping, I think, is the next chapter. Is that
Oh,
what it's
nice.
called? Memory swapping or hot swapping or something like that. Yeah, so I'm gonna keep slowly going through the operating systems book, and then I'm gonna also start doing C++, just more the book that you actually recommended me, the crash course book, because my job,
The Josh
everything's in
Lo
C++.
Spinoza. Yeah.
Yeah, and then maybe in a month or two, I'm gonna start doing some Rust because
Okay.
we have a CLI on the team in Rust, and I've always wanted to ship cargo.
Yeah. Man, that's a lot. You'll be learning all the systems programming languages.
Yeah, I mean, they're similar. Like, I feel like once you learn a couple languages, learning new ones isn't too hard. It's just more like the getting familiar with them enough to be effective.
Hmm.
Because, like, you got to look things, you just got to be willing to look things up constantly. And the AI stuff makes, like, you saw, like, I didn't even need to know how to do what I was doing in C. It just kind of knew what I was doing.
Well, and it was like 75% right. So
Yeah,
it's
yeah, yeah, yeah,
it's
yeah,
important to be
yeah.
able to spot that 25%. Yeah.
Yeah, exactly. That's why you read the books
75% right, but
first.
with a robotic heart of gold.
Yeah, that's why you got to read the books first, and you got to use
Yep.
Claude 4. Dude, Claude 4 is
I think
so freaking good. It's
I
insane.
think that's what this is using. I think it's Claude 4 Sonnet, I think.
Yeah, hell yeah. Cool, man. I had fun. If you want to do it again, let me know. I'd definitely be
Yeah,
down.
yeah, let's definitely do it.
Let's see how the
And
algorithm likes this video. It's probably gonna
yeah,
be
well,
pretty shit.
you can never tell. You can tell.
Never
No pressure.
tell. Maybe people like the dynamic. I don't know.
Right. We kind of
Uh,
bumble along. We make people feel better about themselves.
they're like, if these two fucking idiots can do it,
Yeah,
then anybody
exactly.
can. Yeah, that's how
Exactly.
I
Right. And
feel.
that's kind of true. That's kind of true.
Yeah, that's how I feel, man. Anytime someone says, "Oh, I can't do it," to me, I just hear, "I gave up." It's just like it's just a matter of like brute force effort. Like nobody, it's not easy for anybody. It's just some of us are used to the pain and suffering more than others.
Yeah, it's not the whatever, the dog and the fight and the dog. And why are we talking about dog fighting?
Exactly.
I don't
Yeah,
know. I don't know.
I really like learning C though, because I feel like
Yeah.
it's the closest to real magic in the world that I've ever experienced, like what I thought
Oh,
magic was when I was a kid. Like when I
uh-huh.
kind of blew out my memory, like I'm like, I'm using 20 gigs." That was like, that's a powerful feeling where it's just like the computer just doesn't say no. And it's because of what I said. Like, it's like revving your engine, you know? It feels good.
Y- Yep, yep, yep. Yeah, you've got the ability to use all the cycles for sure. And I mean that like the fact that what like we landed people on the moon allegedly using like tiny computers.
Allegedly. I still think it was Stanley Kubrick.
Okay, yeah. He's a good director. He's a good director.
He directed the moon landing pretty well too.
Okay, okay.
Some might
Well,
say his greatest.
well, on that note, I wish you luck and yeah, let's get back together. I
What are
was
you
very
going to be
impressed
working
looking at
on?
the code you shared, by the way. Good progress on all of this.
Thanks, man. I've been doing all my homework.
Have a good one.
Thanks, Sean. Later.